Deployment of deep reinforcement learning policies in safety-critical systems will require the ability to assure a policy's performance. One reason that deep reinforcement learning policies will fail in deployment is that the operational environment is different than the training environment. This work focuses on a methodology for creating a time series of values indicating when this may be occurring, and an accompanying decision metric which indicates when the DeepRL policy should no longer be utilized. We trained a PPO policy on Meta Arcade Breakout, a video game environment which exposes access to the underlying game configuration. The training environment was the default black background, and we experimented by deploying the trained model in environments with various color shifts away from black. Next, I will explain our out-of-distribution detection methodology that was utilized in these environments. Random network distillation, RND, was introduced by Berta and others in 2019 as a way to efficiently explore during the training of a DeepRL policy. We modified RND in order to provide a time series of out-of-distribution metrics. Our modification of RND consisted of a final activation modification of sign beta x. Adjusting the beta value made the RND vary in different ways outside of the training set. We examined the distribution of the derived out-of-distribution metrics in order to observe the differences in the distributions with respect to change in game background color. We observed that when we did not use the sinusoidal activation function, that almost all of the distributions were not clearly separated. For properly tuned beta value, we were better able to observe this distributional shift. Finally, we used the RND out-of-distribution metric distribution over the training data to calibrate a decision metric. We calculated an estimate of the mean of the RND out-of-distribution metric using a common filter and concluded the DeepRL policy should no longer be utilized when the result was not statistically consistent with the training set statistics.